Okay, today in algebra, we're going to be looking at scientific notation. Now, part of this will be a review because we went over scientific notation as middle school students. But we're going to be taking it to the next level today and actually perform some operations with numbers that are written in scientific notation. But let's just review first what is scientific notation. It's a shortcut for writing either very large or very small numbers. Do you remember the pattern or how you have to set it up? It's always a number that's written between 1 and 10 times 10 to some power. Now, could you have decimals after this number? Yes, you could. But you only want one digit to the left of that decimal point. In other words, it needs to be between 1 and 10. So let's write this one in scientific notation. This is a very large number. So where will I place my decimal point? Between the 2 and the 6. Very good. So I'll write it as 2.674. Now, do I need to leave these zeros on? No. Times 10 to what power? Now, how do I determine the power? Yeah, my decimal point's here. I can't see it, but it is here. So we're going to count how many hops it take to get all the way over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 10 to the 14th power. Now make sure when you write your powers that you put this number very small up in the upper right-hand corner so that you don't think you're taking 10 times 14. This means I'm taking 10 times 10 times 10 times 10 times 10 14 times. Okay, 10 times itself 14 times. Okay, so that's a very large number, and your power of 10 is going to be a positive. Let's take a look at a decimal number, a very small number. You're still going to follow the first step, and I need to write it as a number between 1 and 10, so my decimal point will go between the 2 and the 3. Times 10 to some power. Now which way are we counting? 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be to the negative 9th. Very good. Anytime I have decimal numbers, your power of 10 will be to the negative. All right, now let's take a look at going the opposite direction. Suppose they give you a number in scientific notation. Let's write it in what we call standard form. What's standard form? Just a plain Jane number like you're used to seeing. Not cutting off any of the zeros. So what do I do? If this is 3 and 623 thousandths times 10 to the 12th power, how do I write that in standard form? What will I do? Well, what's this little 12 tell you? Think of it kind of working backwards. You have to count 12 hops. Now, if you think about it, though, you guys are probably past this now to where you can come up with a shortcut because I'm counting how many hops here. 1, 2, 3. So how many zeros will I need to add? 9, because I've got to get to 12. So if I keep going 4, 5, 6, 7, 8, 9, 10, 11, 12. You could do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you just consider that I take off 3 places here, I've got to have 12 places that I'm moving. So I'm going to have 9 zeros. So it'd be 3, 6, 2, 3. And then put your commas in. And remember, your commas separate periods. So this would be, there's your thousands, millions, billions, 3,623,000,000. All right, let's do a small number because we see this is a negative power. We could think of it as moving it over to the left how many places? 2, 3, 4, 5, 6, 7, 8, 9, 10 hops, but it would only be then how many zeros? 9. All right, let's see if that gets us there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I would put it at 10, yes, it would be fine. Okay, so you kind of come up with your shortcuts. Any questions so far? All right, now let's take a look at multiplying numbers in scientific notation. There are some shortcuts that we can use. Some calculators are just too, they can't handle the scientific notation. We're going to try to work them both ways. We'll show you. Just like we did with our other terms, we've been working on multiplying with powers and powers that have the same base number. I can actually rewrite this as 5 or 2 and 57 hundredths times 10 to the 5th times 4 and 65 hundredths times 10 to the 4th. So order doesn't matter. So is there anything that I can multiply together? The whole numbers are decimals, so we're going to punch in 2 and 57 hundredths times 4 and 65 hundredths. And what do you come up with? Okay, everybody agree with that part? All right, times, and then what, because these are like variables that have the same base number, can I do something, a shortcut with the powers? Right, add your powers to be 10 to the 9. Now, is this in scientific notation? Is it true scientific notation? Careful. No, I have to, because this number is bigger than 10, so I need to move it over to the left one more place, 1.19505 times 10. And then what power will that have to be taken to then? To the what? To the 10th? All right, here's what I want you to do. This is a question here. Is it the 10th? Do I go up another power or do I take it down? I want you to punch in your calculator this process. And let's see what you get. Okay, you notice your result that you get is this final answer here, correct? So think of it this way, that if I move my decimal to the left, I'm really actually adding on a power. Let's take a look at our last notes that we had. You notice that if I'm moving my decimal to the left, what happened to your powers? You've got a positive power, they increased. But if I was moving it to the right, it actually was a negative power, or it decreased because it was a smaller number. So you can kind of relate that to what we are doing here. That if this is an 11, and I need to make it in scientific notation, I'm going to have to add another power of 10. Because I'm moving it over a whole place value. Okay, so what's the shortcut? For multiplying these in scientific notation numbers, I can multiply my regular numbers, I call them decimal numbers, and then multiply my two bases of 10, and then I can get my answer. Any questions? Okay, let's try some division. And then let's take our shortcuts. Like we did multiplication, let's go ahead and divide this together first, please. Okay, did you get 0.45? Okay, times 10 to some power. Well, what do I do since these are the same base numbers? And that's something you kind of recognize. It's just like if those were both n's or x's. I can subtract my powers. 8 minus 4 is 4. Now, this is okay. This is an answer, but is it true scientific notation? No, I have to move my decimal one more to the right, which causes what to happen to my power now? It goes down. Very good. If you want it in true scientific notation. For true scientific notation, remember the first digit has to be between 1 and 10. So it has to be less than 10, but it could be a 1. So between 1 and 9. All right, let's try the next one. Let's do our shortcut first. Go ahead and divide your decimal numbers. Give me a thumbs up when you're finished. Okay, so you get 62 hundredths times 10 to the 5 minus negative 10 means you add its opposite, so you get 10 to the 15th power. Is it true scientific notation? No. Move it over 1, and I then get 10 to the 14th power. Okay, let's check yourself. punch the entire problem into your calculator and see what we get. All right, so that concludes our lesson today on scientific notation.